Okay, bits and pieces about Android development. This will lead into the code in a little bit, but I'll quickly talk about it. They have some sort of a different way of looking at things. They basically follow the model view controller stuff for their development of UI apps, and that's pretty standard, but they call things a bit differently, and they have some odd little ways of doing things. So they have your basic piece, which is called an activity, is actually your view. Why they call it activity is because they call the components views, which makes life really, really confusing when you're trying to develop stuff and used to looking at other code where the view is the big conglomerate piece, and now you have view being the little tiny piece in Android. But it all works nicely. They have intents, which is the kind of inter-process communication device inside there. And because of the nature of a mobile platform, you want to be able to free up resources as quickly as possible if you need to. So inside your application, you have different activities, and you use intents to shift between them. And once you're out of an activity, Android has the option of shutting it down and closing it off entirely. So you can persist your state at that point. It gives you a call that persists the state, but it may not be running. So switching between views is a little bit more complicated than it is in normal applications where you go, I'll switch to this view and then back again. You may have to find that you've got a load and save state in between those kind of calls. Intent receivers for listening to published events coming from other things. You can make your intents public or private to your application depending on whether you want people to intercept them or not. This is really nice because if you don't like the way anything's done in Android, for example, the mail client or the messaging client, you can register your application to listen to the intents for messaging, and it will override the Android application for it, and now you're the handle for messaging. You do all the messaging stuff, it comes to you and you alone, and if you choose to do it well, you know your app is better than theirs. If it's not, not so happy. Content handlers is their kind of model for exposing your data to other applications and the thing. So for example, there's a content handler for the address book, there's a content handler for the message store and things like that. So there may be other people who want to look at it, that's how you do it. And finally they have services which are just regular sort of unit style services where they run without any UI. Okay, cool things that Android gives you. This list wasn't here at all last time I gave this talk because I didn't know any of these things back then, but now I do, so it's all good. The mapping stuff done in Android is really good. It's built into the application, you get a component that you can deal with. It's got a very nice stack of overlays framework that you just insert your overlay into and tell it how to draw the overlay over the map. Done and dusted. It's real easy. Their default overlay that they give you is a My Location overlay, which has my current location on it, and you just switch that on, and compass on it if you want to switch that on, and it just works. You don't have to do anything. It connects up to the GPS, receives the events, displays the location on the map, does everything real nice for you. So it's extremely well done, it's extremely easy to use, and you'll probably see lots of cool mapping applications come out of that with Android. Second, the browser. The browser usage in Android, I've done a fair bit of mobile phone development on different platforms, and using the browser in Android is piece of cake compared to anything else. There is an intent to say open URL, and you pass it a URL, and that's it. It launches the browser, that's as simple as that. It's one line of code. Really easy, no management, no nothing else. Android will shut down your activity when it switches over to the browser, load it back when you come back from the browser. It's all just handled for you. Extremely nice. Preferences. You can see in Android, it's been written by some people who've done coding over the years. Sometimes you come across things and you think, if you'd actually worked for a while in the industry, you wouldn't have done it like this. Some of the bits of Android maybe fall into that camp, but there's a lot of it where you look at it and you're like, you're somebody who's been around, you've done a few of these things before, and you've done this the nice way, the way that it is easy to use. The preferences screen is all set up for you. It's extremely straightforward to configure. It does all the saving of it for you. It does all the loading of it for you. The persistence is all handled internally. You don't have to worry about it. You just say, I want a preference screen with checkboxes here and titles here and labels here, and they call them spinners. They have spinners for their drop-down lists. And it all just handles it nicely. You connect to a resource file that has all that described in it. You do nothing else. That is your preferences sorted for you. And when you get stuff in and out of preferences, they have nice things like their preference calls have take the preference name that you're trying to get plus a default value for it. So you always get a default value. You never have to deal with the if-null problem or anything else. It's all very nicely handled for you. So just cute things like that I've just done to make your life a bit easier. SQLite, there's a fully, I'm not quite sure how fully, SQL compliant database on the phones, which you can use for your applications. It runs really well. It does most things you want. There's a few little holes in it and things that it doesn't do, but on the whole, it's a hell of a lot better than Java record stores, which is what we had in Java ME or anything else. So you've got the backing of actually being able to write database-dependent applications on the phone, which you've never been able to do in any other phone platform that I've seen before without porting third-party tools to it.
Do you do web development for iPhone, or have you?
No, haven't done any iPhone stuff. Don't know Objective-C. Supposedly taking on an iPhone project in a couple of weeks, but I haven't done any yet, so I can't compare anything there.
Do they provide an ORM of any sort, or do you have to read raw?
For SQLite, it's all raw SQL. I don't know if there's any available. I've never used one. Our stuff is so lightweight that it's phone software, so there's not masses of data structure there. Potentially, I suppose, you could use anything that can talk SQL and can plug in a SQL engine on the back end of it because it takes raw SQL into it, so you should be able to. They have, the SQLite components have a few sort of, how would you describe them, buildery-like functions on them, so you can say, instead of saying, I want to write a raw SQL statement, you can say, give me this table, these columns, this where clause, these things, grouped by these columns kind of thing in a buildery kind of fashion. But it seems kind of weird because the where clause you have to pass in is a raw string, so by the time you're writing your where clause string, I'm not quite sure what the advantage of doing all the rest of it is. Resources. Google has abstracted everything out that sort of is static content, if you like, in your application into resource files. So there are resources for your screen layouts, there are resources for the internationalization of strings, there are resources for array lists that you want to keep, there are resources for something else, there's 4 of them. They've done it really nicely, it's all XML, it's pretty straightforward. The plugin for Eclipse handles the code completion and stuff for it, so you can get it. And when they get read out at compile time, they turn them into an R file, so there's an r.java file, and they're all referenceable inside that, so you can just use them directly in your Java code by IDs is the other one they have for different pieces, and you can just do r.id. Whatever your thing is, and you get code completion for it because it's part of your Java class. You don't have to worry about how the resources are handled in there. It's extremely well done. On-device debugging. This is a great thing. Doesn't exist in Java yet. Apparently, the current Java JVM for Windows Mobile now will let you do on-device debugging, but it's the first one ever. The on-device debugging for Android came out of the box. It was a 5K zip file or something of USB drivers for your Android phone, and then you just plug it in and it works. The emulator controls that you use to run the emulator on your device. If you try and do any of those with the device plugged in, it just chooses the device by preference. There's an option to say use the emulator anyway, but it will just use the device by preference if it's plugged in, and so everything runs exactly the same as it does when you've got an emulator. You just have to plug the device into your thing. It's beautifully simple compared to every other on-device debugging thing that I've had to set up in the past, which has gone from disastrous to really disastrous. It's completely simple. And of course,
does that mean breakpoints and things like that?
Sure does. Breakpoints, inspection of the stack, everything you normally can do in a Java debugger, you can do pretty much in the Android debugger.
So what you're saying, you plug that into the iPhone?
Into your G1, yeah.
And then that's your IDE is on your PC?
Yep.
And
you go debug, and it pops up on the thing, and the only difference you get is when it pops up your app on the device, it says, now waiting for the debugger to connect, and it takes, I don't know, 2 or 3 seconds to connect the debugger to it, and then breakpoints happen, your app just stops running on the phone, doesn't do anything. You press step, the next thing happens on the phone, you press continue, and stop at the next breakpoint.
Wow.
So there's been quite a few devices that have had on-device debugging, and mostly they just work in a similar fashion to the Android one, but they're a pain in the ass to set up usually. Mostly they require proprietary kits from the phone developers and all sorts of funny things that need to be done to the device. The only thing you need to do if you get one of these to do this is somewhere way down in the settings menu there's an option to say I want to have on-device debugging via USB, which you have to turn on the phone because it won't do it by default. That's the only thing you have to do, turn that setting on, and it's all good after that.
What's in the USB?
It's USB to your computer. And it's open source, so you can go and look at the source code and see how they've implemented everything. It's all there. It's pretty messy, as I mentioned before, but it is very cool.
Is there like a global logging for errors and things like that?
Yes, there is.